So this is Mole Vodcast number 3, and number 3, there's actually two number 3s in your packet. This is the first one. Just make sure you're looking at the notes for percent composition. Okay, so we're talking about percent composition in this vodcast. All right, so percent composition is basically how much of a certain particular element does a compound contain. So how is the composition of a compound determined? All right, so we use this thing called a percentage composition. So because sometimes, it's handy to know how much of a certain type of element is in a compound. Okay, then we can identify that compound. Okay, it's usually an experimental technique that we'll look at in class. But the percentage of the percent composition is basically what a compound is made of. The percentage by mass. Okay, here's the definition of it. Percentage by mass of each element in a composition or in a compound is known as the percentage composition. All right. So how this relates to real life would be in appliances. Okay. So each appliance you see in Home Depot or Lowe's or any other appliance store has usually an energy efficiency tag on it, a yellow tag. So it says on there, like how much you can budget for this appliance in your yearly budget, or how much it's going to cost you to run this appliance for a year. So how they come up with that number is they look at how much energy it uses. So for instance, your natural gas appliances, they get that number by looking at how much or how efficiently that appliance burns natural gas. So remember, natural gas is a type of combustion reaction, and it uses a sample of hydrocarbon. Okay, hydrocarbon just means carbon and hydrogen. Okay, remember, it's some form of carbon, some form of hydrogen. All right, remember, when I burn that in the presence of oxygen, remember, I add oxygen to it, it gives off a certain amount of CO2 and H2O. Okay, and you can determine that amount by using stoichiometry, which we're going to learn about. And that should be a certain number for a certain amount. Okay, if it doesn't match that number, then the appliance isn't very efficient. Okay, for instance, they give that number on the appliance based on how efficiently it produces H2O and CO2. Okay, so that's how they come up with that number. And they need technicians to do this. Okay, so this is a very applicable part of chemistry to real life. Okay, so they have these analysts that measure these amounts and that work for the Environmental Protection Agency, the EPA, that gives these amounts. All right, so that's a kind of an application of it. So what is the percentage of composition in a particular compound? And the compound we're going to look at is copper 1 sulfide. All right, so copper 1 sulfide. So your first step in figuring out the percentage composition of any problem is write the formula correctly. Okay, so remember to write the formula correctly. These are all going to be ionic. These are all ionic, pretty much, okay? If it's going to be a covalent, it'll have a prefix, okay? But if I want to write the formula correctly, I got to write out the ions. Copper's a +1, and if I look on my periodic table, sulfur's a -2. So my formula should be Cu2S. All right, and now I want to write down how many atoms of each element I have. So my formula says I have 2 atoms of copper and 1 atom of sulfur. Okay, so that's pretty simple there. So now I want to determine the molar mass of the compound. Okay, as you know, we had 2 coppers and 1 sulfur. And I want to add those together, but I'm going to use the atomic mass, okay, the molar mass on the periodic table. So I have to do 2 times the molar mass of copper, which on your periodic table should be around 63.55. And then I want to add that to 1 atom of sulfur, which should be around 32.07. If I do that, 2 times 63.5 plus 1 times 32.07, I should get 159.17 grams per mole. Now remember, my units for molar mass are grams per mole, so I've got to put those there. Now I want to divide each atom, each individual mass, by the whole. Okay, so I want to take these numbers here and divide them by my 159.17. All right, so 2 times 63.55. Remember, I want to find a percentage. All right, and then I want to divide that by 159.17. These are both grams per mole. And when I do that, I should get 0.7985. All right, and remember, when I put the same units on top of each other, grams per mole and grams per mole, those cancel out because identical things cancel out if one's on the numerator and one's on the denominator. All right, and I want to do the same thing for sulfur. Okay, so I have 32.07 divided by 159.17. So I want to do each atom divided by the total. These are grams per mole. Grams per mole. If I do that, that's going to give me 0.2015. Okay, so those are my decimal percentages of each element. Okay, my decimal percentage of copper and my decimal percentage of sulfur. So if I want to convert that to a percent, I've got to multiply those by 100. All right, so that's step 5, multiply by 100. So I take my 0.7985 copper, multiply it by 100, and that gives me, well, 79, just move the decimal place 2 places, 79.85% copper. I do the same thing for sulfur. My 0.2015 sulfur times 100 gives me gives me 20.15% sulfur. Okay, so remember, if I'm trying to find a percentage, it's going to add up to 100. So this is one way I can check myself. Does it add up to 100%? All right, so add those two together, I get 100%. You should get, it probably won't be exactly 100%, depends on how you round your molar masses, but it should be pretty close to 100%, 99%, 98%, something like that. All right, so my answer would be 79.85% copper and 20.15% sulfur. Okay, so now there are a couple practice problems down there. Now I want you to pause the video and work out those two practice problems. I will give you the answer to the first one, and then I want you to write the answer to the second one in a response form. Okay, so pause the video right now, take a few minutes, and work those practice problems. Okay, so on the first one, you should have gotten 44.4% sodium, 11.1% carbon, and 44.5% oxygen. So that's sodium carbonate. So one thing you may check if you wrote the formula correctly, that may be the starting point if you didn't get those numbers. So go and check. This should be the formula for sodium carbonate. All right, and also once you get the second one, enter that into the response form. Okay, and this one is a little trickier. Your formula should be Fe2SO4 3. Okay, so if you didn't get the right answers there, we'll check them in class.